Hello my dear students. In this video I am going to discuss the third chapter in physical chemistry, that is liquids. In the CBCS syllabus, in the liquids chapters, mainly we are going to discuss four important phenomena of liquids, properties of liquids. You know the properties of liquid and the concept of liquids. The properties of liquid, it is not new to you people. You've already studied some of the aspects of the physical states of matter, that is liquid, gas and solid. And you know why some substance exists as a liquid and some as a gas, some as a solid. And you know the relationship between the intermolecular force of attraction, which is responsible for the physical state. And you also know the temperature and pressure, so which are also decides the physical state of a matter. When we come to the liquids, in this chapter particularly, we are going to discuss four important properties of a liquid. So one is viscosity, second one is surface tension, a third one is Paraker value, and fourth one is refractive index. So now let us discuss one by one. Dear students, observe this picture properly and you please observe something which is moving. In this picture you can found that there are three bottles in which the liquid is flowing. In the first case, so this is a colorless liquid, so the velocity of the liquid is very high, so fastly it is moving. And the second one is it's an oil, so it is slowly moving. And third one is honey, so it is slowest. So now you have to think that, so why these three liquids moving in a different speed? So what are the factors which is responsible for the velocity of the liquid? Okay, you start to think. Then take this example and you observe this animation properly. So in this animation, so we have taken a three measuring jar, and we have filled three different liquid 1, liquid 2, liquid 3. And in all the three liquid, we are going to place a same spherical ball of same mass. And if you place the same mass at a time, you can find that the first one, so as soon as you put, immediately it reaches the bottom. And the second one takes some time. And you look at the third one here, it takes so much of time to reach the bottom. So why this happens? Even though the mass of the ball is same, and even though the capacity, the volume of measuring jar is same, and we have filled same volume of liquid in all the three measuring cylinder, there is a change in the moment of the velocity of a ball inside the vessel. Why this happen? Start to think. Oh, what nature of a liquid it is responsible for a different velocity of a same sphere in a same measuring cylinder? You start to think on it. Then, so let us consider a river in which a boat is flowing. Here, when the boat is flowing, we can observe that. So so this is a boat, and you assume each spherical ball or assumed as a water molecule, water particles. These are all water, but to understand, so these are the water particle, these are the water molecules. When the boat is flowing, the water which touches the bottom of the boat, so these particles also moving with the speed of the boat. But if it comes deeper into the river, at that moment the velocity of the water increases. For example, in this region the velocity of water is same as that of boat, but if we come to next layer, the velocity is less. If we come to another layer, the velocity is even less. If we come to another layer, the velocity is even less, and if we go deeper into the river, so at some stage, so it is stationary, the water is not moving. So why this is happens? So why the velocity of the layer which is attached to the boat is high, and so why the velocity of the layer which is next to the layer which is attached to the boat is less? For example, this is layer 1, this is layer 2, and this is layer 3, and this is layer 4. So the velocity of the layer 3 is less than that of the velocity of layer 2. Why? Because there is an attractive force exists between the molecules. So these attractive force which drag the molecule which is moving in a water. So when this attractive force which drag the molecule, it create a friction. For example, a water molecule is moving. So here also in bottom layer water molecule is there. So these water molecule drag the layer, upper layer at that moment. So this is there is a friction occur. So because of that, the velocity of this layer is reduces due to attractive force which is present. So between the water molecule, so between the layer of the water molecule, it attracts. So due to this, so the attractive force which prevents relative moment. So this force is called as viscous force. Got my point? That is very simple. The water layer which is touches to the boat, it is moves with the same speed as that of the boat. But the layer which is below that, layer second, third, fourth, they are not travel with the same speed. If you move deeper into the sea, the velocity decreases at the end. At the bottom, the water almost stationary. This is arises due to the attractive force between the layers. So this force prevents the relative movement of water molecule. That's why the velocities decreases. So this is called as what? So here the viscosity is the force which is acting against the flow of water. That's why the velocity of the water is decreases. The fluid nature of a water is decreases. So this phenomena is called as viscosity. So here viscosity is depends on the force of attraction between the molecule, dear students. So you take these two example. So in this case, so what this is a water and this is a oil which is adding to the automobile engine, and you can found that so here the more viscous is due to what? Due to strong force of interaction between the molecule. So the force of attraction is high, the dragging force is high, as a result the viscosity is high. So in case of water molecule, the interparticle attraction is less, as a result it do not drag the water molecule which is flowing. That's why the viscosity is less. So this viscosity is the property of a liquid when it is moving. When the liquid it is at rest, it's not moving at that moment. So the property of viscosity do not comes into the picture. At that moment surface tension will come. Surface tension is the property of a liquid at rest, but viscosity is the property of a liquid arises during flowing, during moving. So now let us define viscosity. So viscosity is nothing but it is the resistance. Viscosity. If viscosity is exists in a system, in a fluid system, what happen? So the velocity is reduced. So the velocity is reduced. So for that one factor which is act against it, that factor is called as viscosity. So that's why it is defined as the resistance to the flow exhibited by the liquid is known as viscosity. So because of this property, some liquid so flow slowly than the others. For example, glycerin, castor oil, honey. So these are all flow very slowly because they are highly viscous, and there is a strong force of attraction which is present between the molecules of these liquids. And the liquids like water, alcohol, they are so quickly moving. So let us take water and honey. So I think you have experienced it. Honey is a so viscous liquid. Honey and the syrup, the cough syrup we are using. So these are all syrups. They are highly viscous, and water is not that much viscous. And you can observe one more factor, that these viscous or liquids are sticky in nature. Why sticky? There is a interparticle attraction. That's why they are adhesive. They are sticky in nature. And the property of viscosity is useful in several fields. It is useful in industry, it is useful in the field of medicines, and in the industry, especially in case of lubrication and transportation. In pipeline, they are going to identify the viscosity, they calculate the viscosity of the concept. And while spraying, injection molding and surface coating, and while preparing liquid food, especially the concept of viscosity and the magnitude of viscosity is very important. So now let us consider another system in which, the water. So now we understood the phenomena of viscosity in a river on which the boat is flowing. So next consider, say, a liquid which is flowing in a pipe, At that time, you observe the pipe here. So these are the walls of the pipe, and in the pipe, the liquid which is attached to the walls of the pipe, so the velocity is less. And if you move to the center of the pipe, the velocity is more. You observe here, the velocity is okay. The water which is touches to the surface of the pipe, so the velocity is less due to interaction between pipe and the water molecule. But the water which is present at the center, if you goes at the center of the pipe, the velocity will be more. So this decreasing, so in each layer, so there is a difference in the velocity. For example, this layer moving with the speed of 100 meter per second, and this layer moving with a speed of 150 meters per second. The velocity difference is 50 meters per second. Okay, why this velocity difference arises? This velocity difference arises because, so actually this is try to move, but there is an attractive force between the water molecule, so it drag this water molecule. There is a restriction to the flow. That's why the velocity is 100. But when we come to here, the restriction is less. So that's why, so it is 150. So the difference between the velocity is 50. And to maintain the difference between the velocity of water layer or two liquid layer, so we need some force. So that force is called as, so, viscosity, coefficient of viscosity. So now let us define the coefficient of viscosity. So dear students, let us consider the coefficient of viscosity. As I said in the beginning, it is defined as the force per unit area which is required to maintain the unit difference of velocity between the layers in the liquid in the unit distance apart. So that means, so if one layer is moving with as I said, 100 meter per second, another layer moving with 150. So in order to maintain a constant velocity difference between these two layers, a force is required in unit area. That force is called as, so, coefficient of viscosity. Then the mathematical expression for the coefficient of viscosity is given by, so here A is the area of the layer, dx is the distance between the layer. For example, let us consider here dx is the distance, and this is the area of the layer, and the velocity difference du is the velocity difference between the two layers. And the tangential force, why it is called as tangential force? Because the force which is acting against the flow of water, opposite the flow of water, that's why it is called as tangential force. Then this tangential force is nothing but F is proportional to A into du divided by dx. Then F is equal to N here n is called as coefficient of, not n, eta is called as coefficient